So far in this lecture, we have taught you linear regression. So we have taught you a class of functions known as linear models, where the output of the function is linear in its input. We also taught you that typically we don't directly learn the functional mapping on the input data points, but rather we learn some nonlinear representation of our input data points, and then we learn the functional mapping from the basis function, the feature vector or the feature function to the output target values. So in case of regression, we also showed you that we can perhaps use least squares as our cost function or the loss function. And then we also covered the solution, the optimal solution given the linear class of functions and the least square loss function. We showed you how to compute the optimal solution in closed form, along with computing the optimal solution using an online learning algorithm known as least squares. Online learning algorithm known as gradient descent or stochastic gradient descent. So in this lecture, in this part of the lecture, we are going to present you a probabilistic point of view of whatever we have learned so far. So we are going to give you the probabilistic point of view as to how the least square, what does selecting least square as a cost function actually mean. So to learn this point of view, the probabilistic point of view, we'll have to explain you what is known as the maximum likelihood estimate, or simply the MLE estimate for some parameter W, that is the learnable parameter W. In our linear regression model, we assume that the function f is parameterized by some learnable parameter W. So today we are going to teach you the probabilistic point of view, and there we'll cover what is known as the maximum likelihood estimate for some parameter W. So let's begin with understanding the maximum likelihood estimate.